So I'm going to present my screen now. Let me know when you can see it.
Yeah, that's it.
Okay. So today, you can hear me also clearly, yes? Okay. Okay. So today we're going to do a bit of notes, then we would go into design. Have you been able to? Um, ok- I'll ask you later. So today we're just learning about some fundamentals of HVAC. I've spoken about some of these things before, but I would just like to keep re-emphasizing until it sticks. Yeah. So we've talked about the meaning of HVAC. We've talked about how it is designed to maintain the indoor environmental conditions to meet a certain standard. Then talked about how it involves three major things, which are temperature, humidity, and air quality. And the way to ensure that air quality is right is by ventilation. So if it's a place that gets the air quality drops very fast, it needs to have very high ventilation rates. So that's why in some of your designs or in some air conditioning systems, you have some standards that state that a certain percentage must be outdoor air entering. There are even some equipment that are specifically for outdoor air. There's this one they call DOAS. Let's see. You can look it up at your end. Um,
Okay.
DOAS. DOAS. I want you to just be hands on. It stands for Dedicated Outdoor Air System. And it basically is like, how do I explain it? The major use is that it brings in outdoor air and then supplies it into the space to support the main air conditioning system. So in spaces that have like large crowds gathering, or maybe like um, churches or eateries, restaurants, such places where the outdoor air needs to be quite high. They usually support it with systems like this. That is if the main HVAC system does not have a robust outdoor air support system. So, so I mentioned ASHRAE, and this one, this particular chapter of ASHRAE is talking about thermal comfort. So, um, it defines the environmental conditions in which occupants feel thermally comfortable. Obviously, you can't make everybody comfortable. So 80% is just okay. And it depends on six factors, which are temperature, dry bulb temperature. When you talk about temperature, this is what we're referring to. There's also wet bulb temperature, but that one is not, that one usually refers to humidity. Yeah. So which is the number two here, humidity, and that involves the moisture content in the air. And if you remember correctly, there's an effect that high humidity has on temperature. Yeah. So let me ask a question. What do you think happens to what do you think happens to the ability of air, yeah, to change in temperature when the humidity is high? Does the temperature increase or does it reduce? Or basically, the higher the humidity of air, does it make the air to absorb more heat or less heat?
Yeah, the humidity of the air.
Mm. Does it result in the air being able to absorb more heat or less heat?
absorb more heat.
Okay, that's correct. But you need to like read more on it. So yeah, so when the humidity is high, the room tends to be hotter because now it it tends to absorb more heat. Yeah, yeah, and you now start seeing things like condensation happening and sweating too. That's why most times the humid location is stuffy. Yeah, yeah. Okay, so air velocity just has to do with convection, flow, bulk movement of air, and that improves heat transfer. Yeah. So I mean, these are the things that you need to like that this principle, this 55 puts into consideration. Then mean radiant temperature, this just has to do with like radiation is like heat transfer without like a medium of transfer. So whenever the sun is sitting on a solid surface, even if there's a vacuum in between, there's some heat that's being transferred. So that's a result. There's like some temperatures of depending on the ability of that body to absorb heat. Some absorb it fast, some don't, some release it fast too. So all those things will affect like the amount of heat in that space. Then personal factors, human factors are like metabolic rates, like and that one changes with your activity. So that's why in a place like an office, is lower. When a place like a factory is higher or a gym. Then you have clothing insulation. So clothing insulation is the layers of clothes you're wearing or the insulative capacity of the clothes you're wearing. And these affect um well basically these six things are the things that this particular attribute 55 puts into consideration when determining the thermal comfort of a space. And these are things that you need to have at the back of your mind when designing a space because and it also helps you paint a picture of what that space is used for so I can design appropriately for it. Remember when I spoke about um, rounding up the airflow? So when you get like a minimum airflow, knowing what that space is used for can enable you know how much you can round it up to. So next, why this matters, yeah. So it helps to determine the sizing of the AC you put in that space, and it also ensures that you are able to ensure comfort, but without overcooling drafts or consuming unnecessarily high energy, just to ensure that you're designing an optimal system. Then it also helps you to evaluate the type of species and to put a system that matches accordingly. So now there's sensible heat and there's latent heat. Sensible heat is mostly measured by air temperature and latent heat, and you see the sources here: sunlight, equipment, occupants. Then latent heat is mostly measured by moisture in the air. So you can see some of the sources here too, from occupants, sweating, and all of that. Then why is this critical? Because as you are designing your space, the whatever equipment you're selecting has should have the ability to handle both sensible and latent heat. And when we are going to get to a stage where we would design or where we would do load calculations, energy load calculations, and that was what is going to enable us to put all this into consideration and like get the actual load, cooling or heating load as the case may be. So now, psychrometric chart reading. If you remember correctly, I mentioned I should look through it. Yeah. So this is not something that you just stumble into. Something that you need to uh, understand the basics of. So I would like to ask that you go and study it again because the more you study about a thing, the better you're able to design. Yeah. If as a designer you're able to finish a project in like an hour or less is a function of how much time you're able to study the background and how much experience you have. So all this knowledge is actually really necessary. Yeah, you might not always need it, but it's important that you understand the key concepts here. So I'm not going to do the reading for you. You have to, I'm sure you learned it and then you just have to go over it again. But also, luckily for you, there are softwares that exist that help you to design these spaces better without like having to trace lines on the psychometric chart. But it's still important that you understand how they work. Okay, so moving on. So we've talked about cooling load before and heating load. Cooling load, it goes with the amount of heat, the rate at which heat must be removed. So cooling load deals with a hot space and removing the heat from that space. And we already talked about some causes of heat, yeah, some sources of heat into that space, which are from like external sources that you can't really control. Although you can, sha, because for example, a solar heat through gain through windows, for example, now when the architect is building, the architect usually has an idea of like where the sun path is, like direct sun path, and then you can ensure that windows don't face that direction. So little things like that can help in reducing the external load on that space. So there's less heat coming in from the window. Then also this selection of materials too for the envelope, which are the walls, roofs, and windows. The materials you select, how their conductive ability is, their conductive and insulative capacity. And then infiltration. Infiltration has to do with like air leakage. Yeah, because no space is airtight. If it is airtight, it would have been more perfect to design such a space, but no place actually airtight. They are leaky, there are always leakages, and then the outside air tends to seep in, and some inside air tends to seep out too. So these are like part of what you put into consideration. Then internal loads. Now this one are a bit under control. Yeah, it consists of the occupants, the lighting, for example, bulbs, equipment. These things also contribute to emitting heat in that space. Yeah, then ventilation load too, the one that comes in from outdoor air. Yeah. So the so uh now methods of cooling load estimation. Yeah, you have the weather data. That is assuming this is assuming you are designing maybe in the 90s or like in the 80s or in the 60s, for example, where there are no softwares. You have to take the data into consideration. Solar angles, all these things. Thank God for technology. Softwares handle this now. So yeah, so basically as the engineer, what you're going to do is that is if you were the engineer in those days, oh, you were engineer in those days, but thankfully you are not. But what to have an idea of like the track list of what you should do is to get the design conditions for that space. Do you know what design conditions mean?
The indoor design conditions are like things to consider. Basically, things to consider that affect affect that will affect the load of your design.
Not really. Design conditions is just what you want to design the space to be like. It's like what you want the space to look like. So you now design to make it look like that. In this case now you want like an ambient temperature, a room temperature of 24 degrees Celsius, and then you need like a relative humidity of 50%. So now whatever that current this design order is what it should be, what you want it to be. Then there's now like a gap between that and what actually existing. So now that process of you now like setting up that space to look like what the design conditions are, now that's where the engineering is. So you define what it is and then you find a way to get it to that level.
So, like, sorry, just now,
No, design condition is what you want it to be. For example, now when a room is hot and you turn on your AC and put it at 16, you have set that 16 as what you want it to be. Now the AC is going to work against whatever is existing to make sure it comes to that 16. So that is what you have designed it to be. That's like the standard you want it to be. So you're not like designed to make it to be that. Do you get? So this is just like an average value. Now this value you're seeing here is just an average value, yeah, of comfort, like an acceptable, just like how in Nigeria, for example, the room temperature is 25 degrees Celsius. So that's like comfortable for a lot of people. But on hotter days, you will need it to like it if when the thing rises, you now want to either bring it down to that or lower than that. Yeah. So then you now also need to understand the outdoor design conditions. So in this case now, if it's a hot climate now, the outdoor will be higher than this. So you're not designing for it to, so it means you're going to be doing cooling in that case. Then next you calculate the loads and then the external, the internal, and then um, you also put this ventilation and filtration into consideration as well. And then you read from your charts and you're able to like get what you want, basically. So that is that for the notes of today. So I'll stop sharing now and I'll share my whole screen so that we can design um design okay between those two works have you like studied and understood that second one better? This is the file that came in. Yeah, this was the architectural plan that came in. Sometimes you may not get an architectural file in a drawing format like this. You may need to extract it from PDF. So how you can do that is you go to Insert, PDF Import, uh, and then you go look for that project wherever it is. For example, now if they send you PDF now, because sometimes this is rare, it's not all the time. Most time they send you a card, but I'm just assuming that you might have such a challenge. So before it happens, let me show you how to do it. So you've seen that this is that same PDF I sent, yeah, and I've selected the page that has the drawing on it. So let's import it. Can you see it now? Can you see it here? So this is it. So then you see that it is now a card file. So you can now select things that you don't need and delete. And then whatever you have left, you work with. Yeah. So you can just take this out and copy it out. You can move it here. This is to move. You can move it to wherever you want it to be. Okay, I want to put it close to the other ones. You see, it's a different size now. But now I can scale it. Pardon the rough nature of my drawing sheets. Whatever I will export is going to be much neater. It's just that sometimes you need to have a rough sheet so that some things you may need to refer back to them sometimes. So now I'll need to scale this thing to the correct scale. You see, it's way smaller than this. So how I do it is that I use the align tool. So I'll measure this. So this line is the length of this place. Then I copy this line out. Oh, I'm forgetting that you don't know that you don't use. So I use copy. Then take this line. I use F8 to change it from, okay. Now I want this line to be, remember that this line I took out was the length of this place, right? Okay, before I do that, let me move it up. Okay. I want to group these projects that it does not scatter. Grouping, if you notice, if you select one, is different. There are different things. See? So now if I group it, I'll select everything as one. Then later, if I want to, I can ungroup it if I want to later. So to group, you type in group, see it here, GR, and then group comes up. So now this whole system is selected as well. So now I want to align this. So now I'm going to use what we call an align function. So type it out. This is it. And then remember that I selected this before I did that. So now I'm going to select this to this. Okay, wait, let me make it easier. Let me make it easier. Let me make it easier. So that I can easily trace it. So now let's do that again. So select this, then align. Then now you select this, that point that I want to align to. Select this end. Yeah. Select this other point. Yeah, select the other end. Because you want to align this into this shape, into this size. This is a method of scaling. Then you press enter. Now they'll ask you, do you want to scale on alignment points? Yes. So now, because you selected this now, it has been scaled to meet the size of this thing. So you basically, that was like a reference point. That line was a reference point. So now this same line that we copied is now the same size as this, right? Now this is for in case you have to work on importing a PDF. So now let's work on the original file that was sent to us, which is this. Yeah. Now if you notice, it is still scattered. I want to group it. Yeah. Okay, I'm just going to delete this. So I want to group it. And when I group it, although one thing I like to do is that anything I want to do, I really like to make a copy. So in case wahala dey, I can always refer back to it. So let's make a copy first. Copy. This is a copy. In case wahala dey later. So now I select it, I group it. Group. Now everything is one. Okay, before I do that, I forgot. I need to change. I like to change everything to one color so that, because if you see, there's a lot of colors that can be distracting. So I'll select everything, and there's this is another way. This is explode. What explode does is that it breaks down every element so that each one is an individual. Now I've exploded it. I can set a particular color.
Okay, so the express is like the opposite of group. Like,
Not really. It's similar, but not really. Group puts everything into one group. Then the opposite of group is ungroup. It takes it back to the way it was for a group is. But explode is more different because in group it might be made up of smaller groups, but explode like breaks it down to the smallest pieces. Like the name implies, explode does not consider the fact that it may have had like other smaller groups within it before. It just scatters it, everything scatters it. Like if you see before, there was this is a hatch, this is a group on its own within other groups. This is a group because a group now consists of like more than one element. But now explode, when I explode it, if you see now each line is on its own. Do you see? So explode breaks it down to the smallest pieces ever possible. So now let's select this. Yeah, I've exploded it. I want to set the color. So now I'm using this green color because this green color, and then I will now like group it back. So that is one green project. You see, that one green project. And I use this green because when I want to print later, green is going to be faint. But we'll come to that later. So now it's grouped. So now let's size this space as if we want to design the HVAC for this space. So now a way to if they didn't, sometimes they may not give you the area of that space. So let's measure the area of this space. Okay, before we do that, let's see the space that needs to be conditioned. So this is the server. This is a coffee shop. This project is a coffee shop. So this part you're seeing here is a servery. And if you look at what servery means, it's like is where they will serve people the coffee or whatever, just in a nutshell. Then this is a cold room. It's like a storage space. Then this is a bathroom. And then this is like an outdoor sitting space. Yeah. Then you can see windows here, windows here. You can see this is a window. But if
Sorry, they just missed. Let me just go back to where I was before.
so, I should wait for a
Sorry,
while. Okay. So let's continue. Yeah. So in that space now we have. It's just that must be the problem. Okay. Eight. Okay. Okay. So we had different spaces. We had a servery space. Then we had a universal bathroom. This is just a bathroom. That's the name of the space according to the architect. So now let's go back to this now. So now the way to measure the area of this space, type area. Okay. Now you measure it like this. You click here. You basically draw around the space you want to measure. Okay, it's bigger than that. Supposed to be here. So, I've seen that it's supposed to be snapping to the point, but it's not snapping, and I'm wondering whether I turned off my snap. Okay, I wonder why. Okay, let me start again. Okay, let's try that again. It's supposed to be snapping. Still not working. Okay, let's try again. See, it's snapping now. So you see when you hover over a place now to show you that point to snap to. You saw how I set it up, Abby? Okay. So I'm trying to draw around this space. So then to zoom in and out, you use your scroll button. So now if you see that selected that entire space, press enter or space key, and you see the area here, 335 square feet. Yeah.
Yeah.
Then only other space we need to condition is this bathroom. Now we measure it again. Area, and then carefully select the four corners of the bathroom. But like I said one time, bathrooms have a standard of 50 CFM per
Yeah.
per WC. That's the standard. Yeah,
WC.
bathrooms per WC. So now I've measured. I've not clicked here. Let me click it. So now press enter, and it gives you the area here, which is 78. So now it doesn't matter because it's not really a dwelling space. 78. Let's record it before we continue talking. 78. You measure it, you record it. This is just for recording purposes here. But we both know that, or we all know that a space like a bathroom is not a dwelling space, not a place people come and go and stay for a while. So even if it's not properly, even if it doesn't have like a lot of air, it's not really a problem. People go in and then go out. So you use that standard of 50 CFM. So I'm going to put 50 CFM in this space because of one W. If there was another, that is 100 CFM. Yeah. So now this is so now that is now we have selected the only two spaces that need to be conditioned, which is this. And I remember telling you that to get the CFM, you do these times this value times 8. Yes. So what does this give us for this?
168 CFM.
268 for the bathroom.
But already, okay, for the bathroom is 50 CFM. Say 50 CFM.
Just multiply the 78 first. Multiply, let's get the value. That is 478. Yeah, but we'll still put 50, still put 50 sha. So this now I remember that I mentioned that you also oversize or yeah what the space is used for. So that space is likely to be a space where people will be gathered and then there will be some equipment there. So I'm going to give it was 268, I'm going to give it 400. Right. Now now I did manual n for this particular space. Manual n is a calculation. We have not gotten to it. We'll get to it eventually. Manual n, this is manual n for this building now. You can see that I filled in the details of the building and then filled in the information, the glasses. To fill in all this information, you need to have an idea of what the building looks like. Then you see all those office equipment I spoke about one time. Yeah, how they also add to the load. Yeah, so this is things you input into the manual n, and then if you see here, you see like at the end we have heating, cooling load, and cooling latent. And at the end of the day, this is the highest load here, which is the heating load. So the total heating load for this space is 35,000, which is roughly 36,000, and the cooling load is 28,000. That is, it adds up all these little loads that make it up, and then this is cooling latent. Yeah, but most time we look at only the heating, the sensible cooling and heating, which is a maximum of 35. So when you see 35, what comes to mind is this BTU per hour. What comes to mind is 36,000. You're rounding it up. So now I know that this space gave you, when we calculated for this space, it gave us 400 CFM. And 400 CFM is just 1 ton. Yeah, by the time you add it to the small space here, 450 is still roughly 1 ton, but 30,000 is 3 tons. So in a case like this where you have your rule of thumb is giving you a different value, and then your your energy calculation is giving you a different value, it's important I follow the energy calculation because there's a reason why there's some information that software has that you don't have. Information about like the location, the climate, the the type of. By the time you fill in all those information, that's what gives you that value. So that value is usually more accurate than what you have here. Sometimes it's close. Sometimes you can have this one, the total sizing is 1 ton. The other one is also giving the same thing, but in some cases, it's not. Some cases is not like that. So in the case where you have to select, you pick this. Yeah. So that is why in this case I'm going to design with that 36,000, which is 3 tons. So now from the architectural file in this project, yeah, another thing I noticed was that the building it had a flat roof. Yeah. So a flat roof that it was look up what a flat roof is. Flat roof usually goes with rooftop units more than any other type of roof because the unit can sit well on it. That's also why I selected a rooftop for this project. And then also the there's no space. Usually commercial buildings have like a mechanical room to place equipment, but in this case there's no such. Yeah. So that's another thing that made me select a rooftop unit. So now it means you have selected a 3 ton rooftop unit for this project. Now And that also means that if you are working with um 400 CFM per ton, that means that 3 ton unit is going to give us exactly 1200. Okay, not exactly, but approximately 1200 CFM. So now I'm going to redesign this piece so that it's going have to be able to like have that amount of air, yeah, that volume of air. So now this is layer. These are layers in a drawing project. So each layer has its own different values or different um details. So like the line, if I draw, this is a sewage layer now. So if I draw a line here, you see what the line looks like. It is a straight line. If I draw it in a vent layer instead, which is a different layer, draw a line, you see it's a broken line. So layers basically is just where you is a way to like separate different drawing, like you want to draw different things, but then superimpose them, but be able to tell them apart. That's what layers are used for. So I'm going to go to, I have a layer for HVAC in this project. So I'll go to it now. And most of the layers coming from the architectural file because they're the ones that really do all the designing. So docs, I have a layer for docs. So this is docs layer now. So now I want to place my air handler here. So let me draw a rectangle to signify that my rooftop unit to be somewhere here. Then I will now draw. Okay, wait. Let me now. I don't want it to be placed like I want it to be placed. I want to spin this around. So so I press here. Okay, I come to rotate. Where's this is rotate. I want to rotate around this point. So this is my base point. Now I'll press F8. F8 makes it so that it moves only in 90 degrees. So this is what it looks like now. I've pressed escape. So now I'm going to bring out air. So like I'll use a line to specify where my air comes out of. So I want my main duct to run like this. My main duct will run like this. I'm down here like this. Escape. Now I would have um mini ducts. This is the main duct. So now I have what will I call it? Let me shift this a little. Yes, I have branch or flexible ducts. So I'll shorten this line. Okay. So now I'll still use line for that. So now I want to scatter that 1200 CFM in this space. So I'm going to put, I like putting my register close to the wall. So this will be here. This will be 300 CFM. Then I'll have another one coming out here. Space bar to open that function again. That command rather. Another 300 CFM here. Then I want um I want to send 50 CFM to the bathroom. So I'll also collect from here and drop it. I try like dropping it. Usually when you're dropping, this is supply for the bathroom now. So you drop it far from the exhaust. No, the exhaust is usually here. So you don't put it too close because if you put it too close, there will be no chance for circulation. So, so yeah. And then I'll drop another supply dock somewhere here. So another thing you also have to consider is like is aesthetics of the space. So now these registers now are like points where the air will come out of. So it will be like the way you have electric bulbs are arranged on the space. You see that it is not just haphazardly placed. So you try to make sure it looks aligned because it's going to be visible for the aesthetics too. So if you notice, it's aligned here. Now, in some cases, you may need to design return lines, yeah, but not in all cases. So now let's design the return line for this. Yeah. So it comes here. There will be an intersection here, but you have to find a way to show that intersection is not does not superimpose. It doesn't pass through it. It just passes over or around it. and now return lines, my return now be on this side. Yeah. So this is something that as a designer you decide how best to do it. Let me do something here. I want to move this. I want to move this. So I come to move. And then remember that I selected F8 and that F8 kept it means that I still moving in 90 degrees. Yeah, okay. Let's now extend this line to meet it. I'm trying to manage my space here. Yeah. So now, okay, this I'll shorten it. Okay. And then let's do other return lines. There will be another return line that I'll place here. Uh, sorry. So I'll place another return line here, just a small return line here, and then another one. Okay, I can just copy this. So I move it up. So now, if you notice, I try to create some distance. This is a small space, so it can be very tricky. If it was a bigger space, it would be easier to like arrange it better. But this is a smaller space, and I have to be careful not to put it too close to each other. So now let's do a text. So you're seeing that it is beginning. This is what my final work will look like. So now let's borrow something from here, which is 300. So this is just text. So I'll copy this and place it here, here. So I'm going to put, okay, okay. And then, so yeah, I was setting the amount of air that I was set into the different spaces. So, so now I'm putting 300 across, and then in this space I'm putting 50. So now I'll select it and then edit it to 50. So now, yep. So this is for the supply. And the return too should be around that same value. So I'll put this same 300. Same 300. Copy. So it means as 300 CFM is coming out through this first one, 200 will come out through this. This is the return. 300 this one has ability to return 300. Same with this and same with this. So now this is what we have here. So now this is an RTU. Let me copy that. So copy. This is just to save time. You can insert a text box. So this RTU. Now I'm going to copy this now and put in a separate file because I have to send it to Revit. So this Control C. So I open a brand new file and place it. Okay. Control V because you know that I had a lot of other items on that page. So I don't want to allow too much cluster. And if you notice now, because this is it doesn't have those layers as before. You see that the lines are a bit different now. Yeah. Although sometimes when you copy out, the layers follow you. Yeah. Some layers follow you. Like you see dock layer will be here. Wait, you can see dock layer here. Yeah, yeah. So it's part of what I'm showing you now. So the architectural file usually comes with some layers that the architect has placed. For example, now there can be layer for furniture, layer for walls, layer for if you look at it now, this is like maybe layer for detail, layer for doors, layer for door frame. Yeah. But it's not something that we really work on a lot. It's just for you to understand how layers work. So when you select a particular layer, it has values that that layer comes with. If you notice, if you hold this is to turn it off or on, that's to make it visible or not. So if I turn it off, if I turn it off, is they'll ask you the current layer, they'll ask you, do you want to turn it off? So now you see that the things that layer are no longer there. They're actually there, but I just made it invisible. So I'm going to turn it back on. So now if you are designing, I have so many layers on, you want to like turn off some so you can see better and design other things. That's where that comes in handy. Then if you want to like create your own layer, you go here. Where is that? These are the different layer commands. Different layer commands. Yeah. Freeze. Yeah. Now layer properties. Yeah. These are layers. Now you want to create a new layer, you come here. And let me be on dock layer. Now this is to create a new layer. Now when you create a layer, when you have had one selected, you can create a new one. It usually copies what was there before. So you notice that it's just the name that you need to change. Let's call it layer one now. Or let's call it duct. But ducts. This is actually not part of this class, so do you know?
Serious. See the whole layer management.
Rather. So yeah, if you notice, let me call it duct for example. Now that is the name. You see, you can set the color of the layer, you can set the type of lines in that layer, select the type of lines. Then later you play around with on your laptop. Then you can select the line width. So line width is just the thickness of the lines. Yeah, because sometimes you need some lines to be thicker. Then this is the thickness in millimeters and maybe transparency. Transparency does how visible it is. Yeah. So let's just go back to this. Yeah. So I copied it here because I want to take it to Revit. So I took it and I'm going to save it now as save. They ask me where this is where I want to save it. Yeah. Call it to Rev. Okay. Save. Now I'll find out, I'll go to that same file. I'll go to that folder where I kept it, which is this. You see it is here. So now I'm going to go to Revit, which I've already opened before now, and I'm going to bring in that file. Let's see, insert. I'm going to do this link PDF, but that this I want to do is import card, which is the format of AutoCAD. So now ask me where am I importing it from? Okay, desktop. This is the folder. This is what I want to import. Yeah. Shortly, you will see why I'm bringing it here. And you see it has come in here now. This is Revit now. Okay. So now why I brought it here is because I want to put in ducts. Okay. So this is option for ducts. So now we also need to size our ducts. So let's go back to, so now, before we do this, let's talk about sizing of ducts. So let's go back. Okay, no, let's just remain here. Let's remain here. Yeah. So now if you remember, this is 300. This is supposed to be 300. This is 300. So I think I skipped this. This was to be 300. So that is total of 300 here, 300 here, 300. That is 900. This is the main dock. Leaving this equipment is carrying 900 dock, 900 CFM. Then you see that there's one going here that's a 950. So that is 950. Remember that our total equipment size is supposed to give us roughly 1200.
1200.
Yeah, our calculations give us 400 CFM for this space, but now we're overriding that with the information we got from manual N. Manual N is like the energy load calculation for commercial buildings. Yeah. So
Yeah.
so that is 950 leaving this. And if it's 1 to miss, you can carry it. So now 950. Now I'm going to size this duct to be able to sustain um a 950 CFM. So I go to this duct sizer. Okay. I put in the CFM I want, 950. And then if you ask me head loss, head loss is amount of the amount that can be lost due to friction and other losses. So I'm going to put a default value of 0.1. You will see that it is giving a it gives you a circular dot. Yeah, that circular dot is average value of 14 inches. You can hear me, Abby? I know there's noise in the background, but you can hear me. You can hear me clearly, yes? Okay. So now, so now it gives you like an average. It assumes that it's a circular dot, but we're not a circular, it's a rectangular. So I'm going to put in 12 here, and then it gives me this other value. So it means the cross section of this dot we'll use will be 12 by 13, but I'm going to use a standard of 12 by 12, which is like the size of dot that's available in. Yes, for a circular duct, but I'm not designing for a circular duct. Mm, I'm designing. I want to design for this. It gives you an option to choose either between circular or rectangular cross section. But what this design is going to be based on rectangular cross section. Okay, so that is
Then just want to regarding the conversion, circular dots.
okay. If you you see that they gave a diameter of 13 here, that means if it was a square, one side of that square is going to be roughly 13 because diameter is like if you put a square around a circle, the diameter of that circle is the same size as the length of one of the sides of the square. So I just took a random value that is close to 13, which is 12 in this case. That's how I got that 12. Yeah. So now when doing dot size, I like to round down, not up, because smaller dots tend to be able to carry F for a farther distance than larger dots. So there's what they call static. There's some pressure. If the duct is very big, the it's not able to travel as far. You get. But if it's smaller, it travels faster. So now basically, if you're passing the same volume of air through a 12 by 12 duct, and you're passing that same volume through like a 16 by 16 duct, the smaller duct is the air tends to go farther. The air tends to go farther. So that's how it tends to um I round down instead of rounding up. So in this case, I'm going to take 12 by 12 because Revit has a standard of even numbers. So now let's put a 12 by 12. Let's draw a 12 by 12. Okay, before we do that, they'll give you space here. You can see here is where you specify. Select your size 12. Select your size 12. So this is a 12 by 12 dot. Bring it down here. Then you click and then you come down here. Then down to the end. Click. Yeah. Now, now, in a lot of cases, as you travel further, the air that is traveling tends to lose some of its velocity, some of its force, some of its energy. So you need to reduce the size of the duct as you are traveling. So I'm going to split these ducts now. Yeah, so I'll select it. Uh, yeah, there's a split option somewhere. Yes, split. Okay, let's split it somewhere here. Yeah. So now when you split it like that, each of them is a separate duct. Now I can adjust this one and reduce it. So at this point, after it has dropped this 350, you see that what is left in the duct is 300 and 300, which is 600. So let's go back to that duct size and put 600 CFM. 600. You see that's giving me a size 11, but here I'll let me put 10 and see. So now I'll put, this is 10. So I'm going to select 10 by 10 because Revit does not allow odd numbers. So now this dock I'll set it to this size 10 by 10, which is this and this. You notice now that's reduced in size, and because of Revit has like the feature that adjusts accordingly. So now, if this was a much longer dock, when it drops off some air again, I would have cut and adjusted somewhere here again. But I wouldn't. I just don't want to do that in this case. Yeah, because this is not a very long dock. So now, this size of dock now, because it's more than I can carry this 600 CFM comfortably. So now for the return, it will be similar. If you notice, return is just at this point it takes in 300. When it gets here, it takes in 600. It gets here 900. So the return line is 900. So we did 950 and we got 12 by 12. So for this too, we can also do another dock too. So 12 by 12. I want to drop it somewhere here, and then I will now draw another duct from here. Call it, let's size it 10 by 10 because it's basically the same thing. Yeah, it's similar sizing. So let's draw from here down here. So these ducts I'm drawing are just the main ducts, the main solid ducts. I'm not going to draw the flexible ducts here. So now I'll take this file now. This is all I needed this Revit was just to give me this duct. So now save this, Control S, save this, that same folder. This is a Revit file now. I'll call it to okay, let's call it back to back to card. Yeah, these are just like some shortcut way of I prefer to, like my own case design practices. So I save it. It's in that folder. So this is saving now. I hope the noise in my background is not disturbing. Okay, are you there? So now let's go back to that folder. The folder. Oh, sorry, I was supposed to export that file, not just save it. I was supposed to actually export it. Export it. So now let's export. Export is file. Export as there are different options here. So I'm going to export as a card format because I want to use it again back in AutoCAD. So next, yeah, this is the one that shall put as back. This is back to card, yeah. So now you've seen the name to be a card file, like a drawing file for AutoCAD. Okay, that must have completed by now. So now we go to that same folder, and we should find that file here. And look at it here. Now what it has done is that it has added that docs for you. Why I needed to use Revit was because I needed to get those sizes. I could have easily drawn it myself, but I just wanted to do like the good case practice of getting the sizes right. So now you can see these docs are here. Yeah. Some of them are groups, some of them are not. So now I'm going to select all of them and take them back to the explode them. How to explode them? Explode. Yeah, because I want to change the colors. I'll select it again and take it back to the dock folder, dock layer rather, and then I'll set this part of layers. I'll set the color to align with the layer color. The layer color was white. So if you notice now I can delete those initial. Oh, oh, remember this thing is still grouped. Yeah, everything is grouped except what this doctor just brought in. So I will just ungroup it. Yeah, as it comes out of Revit, it's usually okay. Let me explode it instead. So this is explode. So now it's on its own. So now I can select each individual and delete them. You get delete to make sure that my work looks good and presentable. Yeah. So now once I'm done cleaning up this file, I will now copy it out and bring it back to that my original file. Yeah. And when I do that, it will look something like this. Yeah. So another reason why you see that the lines here are thicker, but if I copy it to the other file, it's not thicker, is because I have my line width set here. This is what this is, line width, and it helps me to like I can focus on what I'm designing. When the line width is on, it it shows the thickness of those lines. This line is very thick here. One of these 0.6. If you check in the layer, that's where you can see it. Layer properties for dots. Layer properties. Give me a sec. You see for this thing now, the layer size is 0.6. Okay, so this any line I draw in this layer will be 0.6. This is another importance of understanding what layer, how layers work. But now, despite the thickness of any line, once I turn on or off this line width option here, it uniforms, it makes every line to be uniform, the same size, same thickness. So, but it gets everything gets covered up. So now if I want things to stand out, I will turn this back on. And then the ones that are thick to show that they are thick. So now when it comes back, this is what it's going to look like. So now remember that we have the sizes of those um, dots. So now I will not simply edit and add in those values with my text. So I'll just copy text into this space, for example, edit it and put it 12 by 12. Remember that this dot is 12 by 12, right? Now let's confirm that it's actually 12 because Revit enables you to get the sizing correct. So if you see, this is how to do measurement in AutoCAD. So I selected from here to here, and you see that it's giving me 1 foot, and 1 foot is equal to 12 inches. So this is correct. Let's check for the 10 by 10 size. 10 by 10, this is the measure button. So you come here, go here, and it gives me 10. So it means the sizing is correct. So now I will now add. So after bringing in that file into Revit, I will not clean it up. This now is like it's a fitting. This is like a fitting that connects the flexible dots to the um, main dot. Yeah, and then this is where the value comes. You understand what I'm talking about, right? Yeah. So now this is where the air flows, and then these are the points of the branch, the main dot that the branches form. So this is the flexible dot. I use just a line to simplify it. Revit has its own flexible dots, but I don't really like the way it looks. Yeah, I don't know. I've not checked if the latest Revit has a better looking one, but I'm more comfortable using a line because I don't like too many clusters. The one on Revit is it has like several lines. Yeah. So and then it makes the work a bit clustered and it's not very easy to manipulate because solid docs is just straight, but flexible it moves. It's like an arc. So just to save myself stress, I prefer to just use simpler line to express it. So a lot of design is repetitive activities here. So now I've showed you how to draw a square before. So this is a square. but I just use extra X in the middle, diagonal lines to show that this is a register. Yeah, and that was what was 300 before is still here, but now I've gone extra mile to show you the size of the register because everything is about sizing. So now the air that's coming out from this piece is 300. I'll explain what this A stands for later. It's 300 CFM. Now we need to ensure that the flexible dot we specified can carry that amount of air, not more, not less. And then the register can also carry that amount of air, not more, not less. And to size this, I have my sizing schedule on page 2 of this file. Yeah, and this is it here. Flex dot sizing. This is the standard sizing schedule, and this is the CFM, and then this is the diameter of the flexible dot. So what we're working with is 300. So 300 falls into this range, and that is 10. Yeah, yeah. So that is why this I put 10 here to show that this has a size of 10. Now to get the size of this square here, which is 12 by 12, how I got this was a bit of calculation and manipulation. So this is supposed to carry 300 CFM. Now I'll take half of that value. Half of that value is 150. Yeah. Now that 150, I take square root of it and take the closest um, um, number. So now square root of us, if you take square root of 144 is 12, and half of my 300 is 150. So 144 is close to 150 because if I take square root of 150 to give me like decimal numbers. So now 12 could be a possible size. Now let's go a step higher, 13 by 13 or 13 by 12. Let's say 13 by 13 for example. Now that means if you take 13 square is 169, yeah, and 12 square is 144. So now I choose the value that is closer. 144 is closer to 150 than 169 is closer to 150. So that's why we're going with 12 by 12 for this. Now there might be some cases where the other value might be way higher. Yeah, if you can now decide to do, you can increase this to like maybe 13 by 12. 13 by 12, multiply it on your calculator and check what it gets. If it that can now bring you closer to the value, but most times I like to keep it like even by even number. Yeah, even by even number. So I mean there's a lot of estimation in all of these designs. So now this A, what this A stands for, go to page page number A, the first page. This is the schedule. A stands for supply air, B stands for return air. So that in most cases you use only A and B. There are sometimes you use E, which is, you can also see what these other things are. Remember that we talked about registers and grills and diffusers. So you see that there are sometimes that you need to like force out air. Maybe if the ceiling is very high, and you need, being that this register is placed in the ceiling, you need it to have like force to push the air down to where it is needed. There is what we call a directional diffuser. Yeah. So yeah, that is where this comes in. So that is the type of register, but it has the ability to direct air and also give it some velocity too. So if you also notice, we are using just A and B for this project because this is a very simple space. If you design something that is a bit more complex or a much larger project, that would most time that would make you to include other types of design, other type of letters. Yeah, but most in this case we use just A and B. If you come to a return, you see that we're using B here. So this 300 stands for the volume of air. This stands for the size of the register, supply or return, and then you just go along your um dots and just label it accordingly. So the way I do it is that, being that it is a repetitive thing, I just copy and paste it. But when you copy and paste, remember to edit also. So you just copy this So we'll copy, we'll copy this and bring it, let's see, to this one, because this value just is for the, okay, let's not put it here, let's control V that. So I want to put it here instead. I want it to stand for this. Okay, let's go here. This. So now, if you notice, everything is same except this B, this letter, to show that it is for return. So I will now simply just edit it and put B there. So now this now signifies that this is a 300 CFM 12 by 12 side visa, but it's for return as opposed to the other one that for supply. Yeah. And another way I used to show my return is type of registers. So if you go to page 2 again, all these things I later explained it on, because not everybody I'll be able to come and explain to them one after the other. So you have your symbol and legends. So this is just a list of things we have on the plan and what they mean. So this is supply, this is return, this is supply again, but this is duct. This is grill and register, but this is duct, and this is return. You see a different color because it can look the same. Can look the same. Now you can decide to have a different layer for your return duct. Yeah, you set up your different layer. It has everything else as the same as the other supply duct, but the color is different. Should I show you how to do it, or you have an idea? Okay. Yes. Yes. Yeah. So I mean, if you check this, the layer is still in the duct layer, as you can see here. But now I simply change the color from here. So now when setting colors, you can either, we put by layer, you see that it changed back to the color of that layer. So I'm going to Control Z now. So now by indicating my own color, I did overriding of that, so I can select any color I want here. But this is not very efficient, because if you are doing it for like a large project or like a large number of docs, you now select one after the other. So instead of doing that, you just from the onset, you start drawing those dots in that other layer. I could have created another layer here. Let's see. Created another layer here. And give it a sec. And then click my layer and then edit the values accordingly. And then for that color, I change it and then draw my dots in that layer so that I'll not have to start selecting and editing again. That is one way where using layers helps you to be faster. So now, if you notice, this was to indicate that this line does not intersect. This is a flexible line, and this is the main return dot, and they're not supposed to intersect. So I use this to show that this continues here, but it does not pass through this. And then also you can get the size of this duct from that schedule I showed you. And then D, good. This is another type of direction. Let's go here and check it. Yeah. So D, yeah, D is supposed to mean directional. Okay, I made a mistake when I said directional before. Directional actually meant that, yeah, it's aside from the fact that it means that it is pointing in a particular direction, it means another thing, which means that that talk has been made in such a way. Remember when you looked up dampers, remember that it is made to like push it in a particular direction. So for a bathroom now, there should not be return air. All these other dogs now, yeah, for these other dogs now, they might have air might be able to seep past it. So this one now, the way this you're specifying that for this register, it should be like a one-way valve. And that means that air can only go in and not out. So that is another reason why this arrow is here. So the type of duct register to put here is a one-way type of duct. So that's what that directional means. Yeah. So now this is my exhaust fan. I know it looks like a lot, but it's just a simple fan. This is just how I used to indicate it on plan. And then this is the duct. coming out. Yeah, and in most cases, that duct enters into the wall and goes up to the roof and gets terminated there. Yeah, and then this is just to indicate what it is. So if you go to my page 2, where I was presenting all of this, you see that EF1, okay, page 1, EF1 on page 1 means exhaust fan, exhaust fan, yeah, with its information specification. So now page 2 is where I showed the drawing. Yeah, now you see this is number 1. This one here is a keynote, and it means that there's a 4-inch exhaust duct that is going into the wall and is getting to the roof. Yeah, so all of this will be implemented on site obviously. And then another thing to do when designing for a commercial space is what have I not talked about? Okay. Now if this was a commercial kitchen, now there would have been a cooking area where you would have had our kitchen range. Yeah. And they would have sites for that. But this particular project doesn't come with that. Okay. So this is like where you as a mechanical engineer can make recommendations that okay, it is a standard for such a cooking space to have this. Either they might have overlooked it at some point, yeah, then you recommend because it's expected. So now this is like a calculation that is usually needed for mechanical drawing for commercial projects, commercial buildings. So you need to state the space, and then we'll do the sizing of this another time. Okay, it's not that difficult actually. So let's do it now. So now remember that we got these two areas. So yeah, you go and look up this table. Look up this table. Yeah. But you won't really get much from the table because everything's already here. But just look it up for better understanding because the table gives you better context. So look it up. If you see here now, density from that table, you'll be able to read this value, this 100 from that table. You see air density for that. The density is just basically the number per 1000 square feet, the amount of air per 1000 square feet. Yeah. Wait, sorry, density means number of people. Number of people. Yeah. Wait, wait. Air density is air, then occupants is number of people. So these are like the formulas to get the value. So once you'll be able to read this value from that table, you can see that you can use these two existing values now to get what C is. You can see A times B over 1000. Then this one too, you read it from that table. Yeah. And E2, you read it from that table. And then you will see these are the units of the values. So the dot side, you can easily find the location on that table. Yeah. And this is now you now use what you've got in here, D times C, which is this times this, plus this E times A, and put it to your calculator and you should get this. Now, even though these people do not specify a kitchen range, yeah, any space that looks like a kitchen usually has an exhaust. A kitchen is a space that needs to be exhausted because um, it tends to have contaminated air to maintain the air quality of that space. So also, you in that same table, you see that to get this, you multiply the area by 0.7. That's how you get this value. So this is like a minimum amount of CFM that must be exhausted from that space and then replaced by that outdoor air system. Yeah, and if you notice, being that for this space we took only savory and bath space. So bathroom, these two are two spaces that must have exhaust. Other types of space don't have exhaust. If there was an office space here, you will not see an exhaust for it. It would just be a dash, but it doesn't really need an exhaust. So exhaust is mostly needed where the space has a high level of contamination, either due to the people in that space or the equipment in that space. So that's how to get this table. Then these notes always remain. Yeah. So you always read through the notes to ensure that it rhymes what you have on plan and then edit it when it doesn't. Yeah, and then these are some additional notes. Yeah. Now these additional notes change from project to project. These ones here are standard notes. They are always on projects. Yeah. But sometimes there may be some specific demands in the project that will need you to like add some extras. So that's where this additional comes in. And sometimes you may not add it, sometimes you may. Yeah. But if you notice, these ones usually go with what is on the plan actually. So it's basically like this, but it is specific to the project. There may be another project where maybe we use a mini split to design the system. You will not need some of these notes because mini split is ductless, so you don't need these duct notes. Do you understand? Yeah. Then I mentioned about your, what they call it, your title block. So depending on your company or who you're designing for, you need to design your own title block and fill it in here. That is not for me to decide for you. And then this is your um, page number and information. Remember on page one, it is stated there. Page one, it is stated at this bottom left, bottom right rather. This is like to show, it's like a table of content. It shows you everything that the drawing should come with. Yeah. And this is another set of notes too, which you're supposed to change according to the location. In this case, the California project. So I have to use California code for designing it. And I have to like indicate all of this on it because when I'm generating the file that I'm going to submit, this is going to be there. Yeah. Then sizing this is something that is not part of today's class. We are not doing it here and now. Yeah. But you understand how to size. So this too, we'll not talk about this today. This is some details that the project comes with. Not talk about, you can look at it and then they all have their like titles. Yeah. You can like look them up and see what they stand for in the project, but we won't talk about it today. On another day, we'll talk about it. So yeah, that's pretty much. So now let's generate this file, get the PDF out of this. So if you notice, we still have this open. So I'm going to close it. I've used it, finish already, so I don't need it anymore. Yeah, this is the one I sent to Revit. I'm going to close it. Now I'm left with just this file, which is my main design file. If you notice, there's a lot of roughness around it, and this is just to enable me to like know what I'm adding to the project, what I'm removing, and if I need to refer back to something, that's why I left them there. But in the file that you are releasing, our final output, it won't be there. So to print out, you go to output, go to batch plot. There's plot and batch plot. Batch plot is for when you want to plot multiple pages at once. So you see on this my project, I have a lot of sheets. So this is the main model where I was doing my designing on. Then these are the mechanical pages. 1, 2, 3. Then these are plumbing pages. This project has plumbing pages, but we didn't do plumbing today. So I'm going to delete them because I don't want them to come out with me. Okay, before I go on with here, okay. Then I publish and then I select the location I want it to be in my laptop on my PC. Project is important you know how to. So if you notice, I have a particular type of um, naming files. So now this is an updated file for this. Yeah. So this is the day I worked on it. This is the month and the year. And then this is the project title and other things. And the M means that is a mechanical file. So I select, you want to save. I usually take note in this. And then it does the printing in the background. Yeah. Yeah. It's going on in the background. So now while that is going on, I want to show you something. So now this, if you notice now on this page, this is page one. You see that there is colors. It's not just black and white. Now if I go to the setting, this green, if I go to the setting now, yeah, I can set up how my page will look like when I'm printing it out. So let me modify it. Now, this means it's going to PDF. This is the page size. I mean, it varies from project to project, and most times each designer has their standard page size. This is my own standard 13 by 24. These are other options. But what I use is Artful D in landscape format. Now, I don't change anything else. Unit is 1:1. And then monochrome. Monochrome means black and white, just two colors. So any color, anything that is a color will show as black. And anything that is not a color, anything that is not visible will not show. So it shows only black and then the paper. Yeah, that's all for here. Okay. Now you will see the difference later. So it means all this green now will not be visible in this. See, you're saying it's done. We'll look at it later. This green will not be visible. It will show as black. Now if you go to page 2, there's something different. Now remember that I set this to be green from the beginning, and I said I will explain why later. So the reason why I set it to green was because I wanted to show a different faintness. So let's print this page alone and see what it looks like. Okay, let's before we do that, let's set it. So right click on the page number and then takes you here. Modify. And the only thing I change here is now grayscale instead of monochrome. So grayscale means that it shows, like, depending on the color you select, it shows a thickness or transparency of that line in different shades of gray. So now let's print it out and for you to see. So Control P will just print out only that page. So let's preview what the printed page will look like. If you see now, my white lines, my main lines are now very visible. Meanwhile, the what I set as green is now faint gray lines. Yeah, then everything else is black. What I want to show is visible. If you notice, and what you can see here, escape again. What you can see here, all these are like the main lines. Then this green, because of the what color it is. Now, if I change this green to maybe yellow to show me a fainter gray. So as I change the color, and also if you notice, this this is like this is just like a bonus addition to this class. It's not part of the class. But if you see, this color now does not show as this color. It shows as this color rather. Control P. Preview. This purple. See that the green did not green showed as gray, but this color did not. So now this color is still visible on my display, because why I left it visible is because I have a reason for it. I need anybody that looks at to be able to tell that it is two different types of, yeah. So now how I did that was from the model. You can play around with this later. The main page, when I was selecting these colors, this one, it is under a template where it is under like a pre-selected index colors. These colors here. Then this one is a true color. So there's two types of colors. There's true colors and there's pre-selected colors. So if you come here, this is like, if you select any color within this place, it shows the way it is. But if you select under the index colors, it shows like it shows as it's not shown as a true color. A true color is that whatever color it is the same color to show on the printout. But these other index colors, any color you select here, yeah, it will just show you as the color here, but that's not the real color. It will still show you as the gray color later. So that's just, so you just play around with it and see what you come up with. So with that, you we are done with designing this system for today. So thank you for coming to this space, and I'll take your questions.